Hello everybody and welcome to this tutorial how to model a fan housing in Shapr3D. In this process lecture, I will show you how to model all the required details of a product housing like wall thickness, shell layering, and lip and groove by using a smart sequence of direct modeling steps and only basic sketches. Please feel free to download the shared final design so you can follow this demonstration better and explore the design on your own. Great, let's get started. First, let's take a look at the design actually in this file. I opened the folder overview. You can see I sorted everything nicely for you. There are all the sketches, plus I have everything sorted in for the final design, including, however, also here some of the elements I used to create certain details. And the focus of this video, as I said, will be how to create simply by using very simple sketches and the majority a smart set of direct modeling this design where we have everything nicely shelled, including a lip and groove function, for example, for the shells to snap together. Okay, so let's hide this, and there we are. So the fan is a cylindrical object. Okay, so that means, first thing, I will build a very basic cylinder. Very good, that was easy. The top of the fan is slightly arced. Okay, so I have this shape here, which I will extrude by 100 and then say a new body. Very good. Select this face and then I set this to 200. So you might ask yourself, well, why is the sketch actually not at the right position? Because it has to go a little bit lower. You see, the main reason why I moved the sketch a little bit up as a little trick is it does not intersect with this. I know that this edge has to line up with here. Well, it's easy. Let's select the lower face. Then we go to move. And we move this simply down 10 millimeters. As always, unit systems and the grid make use of it. I'm working here in millimeters. All the grids are turned on. So the sketch is, for example, exactly 10 millimeters along the z-axis too far up, meaning I always need to just move it down by 10. Very good. Then I will select my body and select this object which I created and then select subtract. I don't need to keep any original. Click OK. Very good. So that was pretty easy. Here we can round this 5 millimeters. Very nice. Okay, so at one point I know I would like to have a detail cut into there. This will be created by this shape. And then also the top part needs to be removed. And then I need also to shell and create lip and groove and all this stuff. And the trick here really is understanding when, or better said, in what sequence do I have to model everything. So far that was very easy. Now we need a cylinder and then we can trim it, we can round it. So let's think about, can we shell this now? No, we cannot shell it. Shell is actually one of the commands. So the thicken command we will use at the end. First, what we want to do is, let's maybe model this down a little bit. So I extruded this profile. I would like this face, however, flow along this surface. So I can select this face, select then this face, and say replace face. And done. Pretty cool. While this is actually now sitting on the face, this has to go a little bit into the face. So similar trick here again. I select this face and I go to move. And this is 5. Let's move this down by 10 millimeters. Very good. Okay. So I will use this shape later to cut, split, remove something from that. So let's do that. So I select this, then I select this, and then I say subtract. Okay, but then you see, well, the opening is there, but the other piece is gone. We can select this, go to subtract. Do we have any option here? Removed modified bodies. Done. Look at that. There it is. So here's that one. There's this one. They're actually there and there. So very good. So this is also not necessarily really what I need. Now you see this area still here is missing. Okay, so let's go back one more time. There we are. And what we will do now is we can select this. We can also go intersect and say, hey, keep the original objects. Very good. Then this I can delete. And I end up with the original part and this element. So this is actually pretty good. This is what I want. So these faces, which I'm selecting here right now, I would like to shell at one point. But first, to make the design nicer, I will round, or I can round this by 10 millimeters. Then I select these faces there, select the face at the bottom, and then go to shell, 2 millimeter. There we are. Pretty good. So with this element shelled, now I can go and remove the volume from there. So number 1, number 2, subtract, and yeah, removed body. Okay, there we are. Cool. Perfect. You see how beautiful this looks. Just for the sake of demonstration, if we now actually go ahead and I have to turn off these sketches, select this bottom face and shell it. There you can see how we actually ending up with inside this offset of the surface too. So this is a quick demonstration already about the correct sequence. When do we model what, or what tool do we use? So let's undo the shelling. Very good. And turn this off. Okay, then we can turn the rest back on. Very nice. Okay. So I know at one point I can shell everything. I also have, for example, here a sketch, which I can extrude inside. I will use 36 and then round these two edges. Very good. That's kind of like for the fingers to go in. And if I now do a shelling one more time, so you can see again why the sequence is so important. So when I shell this, there you can see now even this part is shelled too. Okay. And we don't want that to be shelled yet because we need to add also here the front part. So I have this and this, I will select both elements of the sketch and join this. Very nice. And then this edge I will select and fillet, and I will continue pushing the fillet till I will go 20 millimeters. So here I have a really nice, perfect transition. So clean edge, same here. This is beautiful. And to help the shelling, this is just specific to this design, I will bring this in a little bit more. Okay, very good. So I will actually select all this and drag this in there, including this. And then we will call this sketch. That makes it much easier to turn everything on and off. Very nice. Let's take a look. At this point now, I can actually go ahead and do a shelling. You see that I'm selecting two objects now. Sorry, two faces. So I core the whole design out from there and there. Beautiful. And look at this nice detail we have even in there. Good. Okay, so most of the elements are done. And now what we would like to do is we want the top part to separate. And then we want to create the lip and groove. Let's turn on this sketch and we will extrude this 100, 200. There we are. And same steps again. This will go down till there. So this is 20. And then I can pay attention to when I move this down 25. Yeah, it does not intersect there with the fillet. There it is. Good. Very nice. Okay. Beautiful. Another step 2 here is for doing the splitting. I can also make a copy of this, move it forward and then back. And you see now I have actually 2 of these copies. So here I could say mu by this subtract and keep the removed body. Yes, because this is my tool. So you see that got removed. Very nice. This one I will hide. This one I will show. And now I will say U and U. Find the intersecting. Don't keep any original. Just discard it. There we are. Very nice. Cool. See there, everything fits on it. Great. Okay, so how do we now create the lip and groove? Essentially, I would like on this face an extension, or not an extension, a small kind of like element that cuts in and moves it up from the inside and maybe kind of like a step on the outside down. And here pretty much then the opposite. Okay. So ideally we also want to do this in a very easy way. Now, because I have everything shelled already, I have to redo one tiny step. So I will do this one more time. Also here, there, new body. Bring this out. Very good. Then I will show this. That's actually where this will meet. Again, because I'm using the snapping, this will be very easy to just reposition it to that point. There we are. Okay. And now from this, I would like this to be removed. None. Very good. Okay. So here's actually now the funny trick. And that's the reason why I recreated this cylinder. Let's call this LED, so it's easier to see. Let's call this base. And we call this top. Very nice. So the base is gone, LED, there. So check this out. I would like to have a lip inside and going up by 2 millimeters. So I select this face, go move, very nice. And then I move this up by 2 millimeters. There we are. Fantastic. And then this, I will make smaller. 64. There we are. Cool. Okay, so let's take a look at how this looks right now. You see actually how this intersects. Cool, no? And let's actually turn this on, the cut section, so you can better see what I'm actually doing here. So I made it a little bit smaller and then I moved it up. So what I can do now is from this, I would like this to be removed. Keep none. Very good. And there I have my lip. Okay. The problem, however, now is, well, how do we make this intersect with the base when it sits on it but does not intersect? So this interior face we moved in by, or this lip we moved inwards or upwards by 2 millimeters. So this one here, we move up by 2 again. And then these two will intersect. So then from this, I would like this to be removed. Obviously here, keep the original part. There we are. So there we are. There's actually our lip. So you see, very smart direct modeling, not complicated. Okay. So the top is basically done. We have also the LED. That's all nice. Well, actually, since we're talking on with the groove, let's finish the groove. So I have one sketch here. There you see there is this element in there that I actually modeled by hand, kind of like a step. So what I will do is I will select the sketch. It's easier when all the objects are gone. I extrude this up really high, make it a little bit bigger than needed. Very good. There is the part. Here again, same trick to make a copy. Move and copy, number 1, minus by U, subtract, keep the removed body. That's right. So this is the base. And we need to figure out actually what is what there. Intersect, very good. Yeah. And there is now our other lip and groove, the vertical one. So you see that was just simply created by a vertical extrusion of a cutting object and then via the Boolean Subtract, I kind of like split the first design into 2 parts. Super easy. Let's finish this. Here we have our top and there I would like to have 4 buttons in it. Before we take a look at how to do this, let's examine actually the sketch. Also here, very simple trick how I set everything up to work nice and symmetrical. All the circles, for example, are equal. So when I adjust one circle, you see they all update. Plus I have from this point to the circle, from the circle to there and to there, I have all these lines drawn. You might ask yourself what these lines actually are. So I have 3 lines which are equal, and I have then 2 lines which are equal. Here, and check this out. When I set this to 20, there you can see how everything updates nicely. Pretty cool. When I remove that constraint here, and I move this there, I mean, how beautiful. There. Okay. So that's a way how I very easily set up this array. The circles, the center point are coincident constraint on this arc, and then via the lines and the equal constraint, I made sure that everything is nice and symmetrical. The only downside is, as you can see, I have to be careful selecting all and the correct rule files of the sketches. There we are, but otherwise it's not a big deal. Very good. So this will be something that goes down. We don't really know how far, since we are, as industrial designer, I'm concerned with the exterior. The interior is then a next step. And I made a mistake. I just cut actually everything. But I want, of course, I want to keep these holes and the buttons inside. Very good. Oh, there it is. Just jumped for a second. There we are. One more time. We go down. And we will say here, new body. Very nice. And then new. Boolean Subtract. And keep the removed bodies. Very good. So how do we now get actually the surface of the buttons flush to this face? So there are 2 ways. I could, that's actually true, go this way. So I cut, and then these faces 10 millimeters down. Well, that works. And this I can remove. Or what simply will be faster, it's one face, target face, and replace face. That face, this face, and replace. Super easy. Okay. Then I can go ahead, give everything a nice fillet, and finish this design. Very good. And this kind of like nearly sums up how I designed all the shell. As few tips to show you how, for example, I created the inside. I have actually here a sketch, and I will go to this view. And you see the sketch is a little bit inside this body. There you can see this one. So the way how I created this was this way. So I selected this face and then I added a plane. And this plane, I moved in a certain desired amount. I will go 2 millimeter in this case. Then I can select the face with the finger double tap. Then I go on to that construction plane. This construction plane slices kind of through this design. And now I can go ahead and create myself a sketch that is a little bit bigger than the interior opening. So let me undo actually these steps because it's a little bit bigger. There, I can now go ahead and join union, simply extrude a cap that fits in there. And I can do the same down here. 2 and union. If this is not big enough, I can even select this face and move this one up. Very nice. You see, this is all fairly simple. Let me show you another cool trick. So I will select this, then I go to extrude. Extrude this one down by, I make this 2 millimeter and new body. Very good. And let's go to the inside. There we are. I would like to select this face and I extrude this so it's flush with that edge in the back. Very nice. And then this, I can move down 10. Select both. And then this is not 10, this is actually now 20. Careful what you select. Good double tap. And now this goes down 40. So you see very quickly you can create repetitive elements and then we just Boolean join them all together. And for the opening, if you would like to be accurate, and instead of just having a basic from the front, a rectangle cut through, we would like to have an opening that is kind of like perpendicular to the arced surface. So for that, we need to have some sort of a sketch. And here's the sketch. And there you see the part I'm talking about. So it's from the center of the sketch. Sorry, the center of the cylinder. I drew then these 2 lines. Sorry. There and there. Including a horizontal line. So, and then with the dimensions, I was able to make these 2 lines having the same orientation, left and right. And then here I have a nice slice. So this slice, I will move down 10 millimeters. And let's take a look at the rest. There we are. I will go hide the sketch. The edge here, I would like to be rounded a little bit. So I do the rounding here at this stage. And then I move this one down 20 and 40 60, and so forth. And then I can go ahead and say, from this, remove those. Little tip actually, because at one point we will have many of these objects. Put them in a group. Then from this object, I would like everything to be removed inside this folder. I said group before, I meant now put them in a folder. And then subtract, none, done. There we are. You see how easy that is. Pretty cool. And for those who are new to Shapr or direct modeling, another really interesting element to point out, all these details can be figured out and adjusted afterwards. We can even move this face further up and play around. But obviously, that is where a little bit of pre-planning is very helpful, particularly when you have multiples, because you don't want to have to adjust every hole. Then it's actually much easier also to work with copies. And I, for example, in this folder, consumed the solid objects. That is actually why, for example, here I still have the original objects. So do I need to modification too many? I can remove everything, select this one, modify it, and then multiply everything again and do my Boolean cut with the selection of this folder. And that basically sums up what I wanted to talk about. Very smart direct modeling, how to, based on very basic sketches, but then in smart step-by-steps, we can design actually a pretty good looking and accurate representation of a fan housing.